Welcome. Previously, I was stopped from here due to the sounds. I had to stop from this, so I'm continuing from that. So what I have discussed here that we have taken the two systems. One is one is these systems where two pi bonds are there. Two pi means even number of pi bonds. It may be two this type of bonds or any type of bonds. Like it may be like this also may be there. It's 1 2 3 and 4. Here the two pi bonds are there, here four pi bonds are, means any bonds that should be even number of pi bonds that will lies on that 4 pi systems. And like here it has the 3 pi bonds, it means that odd number of pi bonds. Like that any more bonds, like here 3 5 7 9, any number of odd number of pi bonds are there, that will fall under the categories of 6 pi bonds. Okay, so that's I'm going to give the tricks that how will you remember where the bond is formed. So here I just start David. So there is two ways that will form. Either it may be the heat or in the photochemical conditions. Okay, and what that if that is a 4 pi system. 4 pi system means even number of pi bonds are there, and 6 pi system means that is odd number of pi bonds are there. So on that case, what that 4 pi, what we see that on heating 4 pi systems on heating, what will happen, that's I have shown here. On heating, that new bond will form on the cone, means on cone rotatory. Here on cone rotatory that bond will form. So I will write here the on cone bond will form. Okay, now 4 pi systems, here what I say that where it is, yes. So on cone rotatory bond is forms, and other way is on disk rotatory. If it is photochemical conditions, then on disk rotatory it will form the bond. So if it is photochemical condition, then on disk rotatory bond is formed. Similarly, 6 pi bonds, that where bond will form 6 pi bonds. So if we are giving heat, then on disk rotatory new bond will form. So on heating, then this bond will forms, and other is on, and if we are giving the photochemical conditions, then on cone rotatory bond will form. So photochemical condition on cone. Okay, so this is the way that how you see that 4 pi means any even number of pi bonds are there. Then on heating, that heating, then on cone rotations bond will forms. And if we are given the photochemical conditions, if photochemical conditions is given, and then on this rotatory bond is formed. Similarly for 6 pi bonds, if heat is given, on this rotatory that bond will forms, and if it given photochemical conditions, then on cone rotatory it will comes. So this way we can memorize, or for that we can also remember by tricks that what is say that if I say that 4 pi, okay, on heating bond is forming for on heat. So on cone rotatory bond is forming. So what I write that 4 pi, that is heat, and on cone bond is formed. Okay, so 4 pi heat cone, that we can remember. Then that opposite, that is 4 pi if photochemical condition, then that will be this. So if you remember one, then other we automatically that we understand that if heat that on cone will form, then opposite is if photochemical, then that should be this. Okay, because cone on another one is this. So if you say that, if you remember this, then other one we can easily remember that. So 4 pi heat cone, and other one is same things we can remember for 6 pi. So what here cone is forming, so what we say that both sides let's keep cone. Okay. And here what, where cone at the photo. So I will write here photo, and that is 6 pi. So we can remember that 6 pi photo cone. So both also for understanding, for easily memorize, I keep both in con. So I will say that 6 pi photocon, then the bond will forms, and this and opposite will be, for this opposite is 6 pi, that is heat, then that is this. Okay, so this is the opposite of so just remember this, then automatically this will be you will understand that other will be 6 pi heat this. Okay, similarly this remember this one, and for that other one is 4 pi. If it is heat, then that should be a photo, and that con will be going to be this. Okay, so better that we just memorize this, then automatically other will be easily we can memorize it. So what that 4 pi heat cons and 6 pi photocons. So if you remember only these 2 points, then we can easily solve the questions related to how the where is bond is forms and where is not bond forms. Note that here I write that 4 pi means all the systems which have the even number of pi bonds, that will lies under this. Likewise that odd 6 pi, all the odd number of pi bonds. Okay, so that we will discuss while solving the example, so we will get clear more. And one more thing is that is if you have that cone rotatory, then what here that stereochemistry means that here stereochemistry is different stereochemistry that we will discuss here. So if it is a cone rotatory, for cone rotatory stereochemistry will change. Stereochemistry will change, and if it is a disrotatory, disrotatory, then no change in stereochemistry. No change in stereochemistry. So this one also you just note it out that where stereochemistry will change. Okay, for cone rotatory only the stereochemistry will change, and for this rotatory stereochemistry will not change. So applying this concept, we will solve the examples and we will clear more. Okay, so remember that cone, that stereochemistry will change. Cone rotatory stereochemistry will change, whereas this rotatory no change in the stereochemistry. Okay, that's why we also take on the cone. Okay, on the cone that bond is for the heat, and another is photo. Okay, photocon, that bond will forms 4 pi heat cons and 6 pi photocons. And the stereochemistry in if it is cone rotatory, then stereochemistry will change, and for this rotatory no change in stereochemistry in the products. Okay, how it is, by looking the examples we will clear more. So let's start the examples. Okay, so first example is this one. So here what we see that first how will you look that, first we will count that number of pi bonds. So how many pi bonds are there? 2 pi bonds. So 2 means even. Okay, so even that will lies in 4 pi systems. Okay, so if it is a 4 pi systems, now what we look that what I say that 4 pi heat con, it means the heat is given here, so heat, and we will do the cone rotatory to make the bond. Okay, so now how will we make the bonds? So for that what we will do here, another one thing we will note that this is here, this is the double bonds. If it is the double bonds, then this and this this and this are trans. So it means that this is trans, above one is trans, and for this for this for this double bonds, this and this is cis. So this is cis. Okay, so how this double bond is, first double bond is trans and second double bond is cis. So for stereochemistry, how will you look that? That is, here I will write. So if it is trans and one is cis, one is trans and one is cis, then conrotatory that will change the sign. So if trans cis, then that okay, trans cis, then that is assumed as trans. Okay, if it is trans cis, then that is assumed as trans. Now if it is similarly cis trans, that is again assumed as trans. And if it is cis and cis or trans and trans, then that is assumed as cis. Okay, so if it is trans and cis, then that is known as trans. And if it is cis and trans, that is also known as trans. And if it is cis or trans, then that is assumed as cis. Okay, so this has to keep in mind. This one also I will write somewhere. So here I will write that if one is trans and other is cis, or cis or that is trans, then that is always assumed as trans. Another is if one is cis and other also cis, or one is trans, other also trans, means both cis or both trans. On that case, we will assume as cis. Okay, so this we have to keep in mind. Okay, so now we apply this to solve our questions. So since this is trans and cis, so trans and cis, that is assumed as trans. So if it is trans and now we are giving the cone rotatory, then what will that, this cone will change the stereo, so this trans will going to change into cis. So here we will get the product, that is cis. So where that cis, that where new bond will forms, on that types, what are the molecules on that new bonds, that will stereo will be, we will define here. So let's look the examples. So what happened here now, that what happened here, see that this is going to here and this is going to here. Okay, so what will happen, that it is going to becomes 1 2 3 4, so 4 ring will form. Okay, and one is going here and this is going to like that, and these bonds, so for understanding we can make here, this is positive, this is negative, and this is negative. Now this is positive and this is negative, so positive negative make bonds, and this remaining a positive charge and negative charge, so negative positive again make bonds here. So that's form that this for pi systems. Although this intermediate, this positive negative charge, it will not form, but understand it, we can make it. Okay, so this positive negative make bonds, and this positive and negative make this bond. Okay, so that's why this bond has formed here. Now after this bond forms here, that new bond, this is the new bonds form, this is the new bond for. So along this new bonds, what are the substituents are there, that we have to make the stereo. So for that we have did this. So for that we will make the stereo. Okay, so this new bond has formed. So now we will make the stereo. So what are the substituents are there? One side is methyl, another side is hydrogens. So how they are in these new bonds? In these new bonds, these are in the trans, because trans is that's converting to trans, and now we did the quantitative. So they again become cis. So these two, although previously they were trans, now they're going to into change. So it means that this one is going to be cis. Means here also methyl will be like this, and here also it will be like this. Or because now we are getting the cis, or this also can be, if one is like this and other also needs to be like this. Okay, any one is correct. So what I see that where the bond forms along that bond, that stereo, where the new bond has formed along that new bond, we will define the stereo, what we mean the stereo. Okay, so like that we will solve the all the examples. So let's solve another examples. Now if you look these examples, what you see here, so this double bonds, this is trans, again this double bond, this is also trans. Or also we can look wise that you just look methyls. Okay, methyl here, methyl. So this is out, and this is in. So just look only methyl. So these are out. So also we can say that out, that is going to be that out going to be the cis, and out in is going to be the trans, and in is again going to be the cis. So here what that this is both out, so that is going to be a cis. So if it is a cis, because sometimes like we are making trans, we have to understand these bonds. So simply we can say that this is out. Or if it is, so just not look that hydrogen atoms, just look that which is other than hydrogen atoms, that things we will look. And okay, so here that we will not look that out. Okay, sorry, here we will look that out. Okay, so this out means cis. So we will make that, means the how will you rotate, you rotate like this. It means that this is going to be positive, this is going to be negative, and this is going to be positive, this is going to be negative. So positive negative make bonds, and this positive negative make bonds, means that here how many 4 ring will form. So we make that 4 rings. Okay, and here that bond is forming, and this is the new bond set form. Along that we will make that system. So we will make the stereo. So now what we see that this is a heat is given, and how many number of pi bonds? 2 means even means 4 pi. Okay, now if it is heat, and that heat where the bond is formed on con, so so we are doing here con rotatory, and it is a con rotatory. Then now this is out means cis, and if it is cis, then you are doing con rotatory, then that stereo will change into trans. It means that the methyls will be in the trans. It means that one is like this, then other has to be like this. They has to be in the trans. So likewise we will solve all the questions. So moving to the next questions, look here. Here how many number of pi bonds are there? 3 number of pi bonds are there. Okay, so 3 pi bonds. So 3 means odd means we looked at 6 pi systems. Okay, so if it is a 6 pi systems, then where bond will form 6 pi photon, that will the bond will form, but here that heat is given. So other than 6 pi photons, other is 6 pi heat, then that has to be the disk. So here we will do the disk rotations. So for disk rotations, what we see that no change in stereo, only cone, that stereo will change. Okay, so here the stereo will not change. So we will do the rotation. Let's do that. This is going to rotate like this, this is going to rotate like this, this is going to rotate like this. So for understanding, make positive negative, okay, positive negatives, positive and negatives. Now what is it that positive negative make bonds, so this will make bond because this is breaking, so this will make bonds, and this is going to make bonds, new sigma bond is formed, and here again new bond is formed. So if I make it, then how it is going to look like? So how many bonds is formed? 1 2 3 4 5 6. So that is going to form this ring. Okay, and what that 1 pi bond has formed sigma bonds and 2 pi bond is there. So this and this. Or for understanding that, simply make that how it is. Okay, this will make the bonds, and what that this is shifted to this, and this has made bonds, and this is shifted to this. So this is the new bonds that is formed. This is the new bonds that has formed. Now along that we will make the stereochemistry. So what are the stereos are there? So for that, simply look that out and in. So this is out, this is also out. Okay, this out, that is going to be the cis, and here that since that this, so stereochemistry will not change, so this again remain as in the cis. Okay, also you can look that this is the trans, this is trans, and this is also trans. So trans again that will make cis, or we can say that out, that is also going to be cis. So this is the dis rotatory, so stereochemistry will not change, so this again remain as the cis. It means that one is like this, one is like this metal, then other has to be the like this. Means that along this new bond forms will make the stereochemistry of the substituents. Here also be the like this, or this can be or like this. One is like this methyl, then other also has to be like this. Okay, so both are correct. Likewise, we can solve the question. So we will look that the number of pi bonds, that is whether this is odd number of pi bonds or even number of pi bonds. So even number of pi bonds, that is in the 4 pi systems, and odd number of pi bonds, that's lie in the 6 pi bonds. Now moving to the next questions. So these questions, what it says here that how many number of pi bonds are there? 4 pi bonds. So 4 means even. Okay, and even means that is 4 pi systems. Okay, now this is the 4 pi systems, and heat is given. So 4 pi systems, heat, then bond will form on cone rotatory, so we have to do in a cone rotations. So do the rotations here. So just make that bond movement of bonds. So if this is moved like this, then this is moving like this, and this is moving like this, and this is moving like this. Okay, so now what you see that make that positive and negatives. So this is going to be positive and this is going to be negatives. Okay, similarly this is going to be positive, this is going to be negatives. Similarly this is going to be positive, this is going to be negative. This is positive and this is negative. So what we seen here that 1 2 3 4 5. So what we see that, let's say that if we make bonds here, then what will happen that you see that if you make the bonds here, then how many rings will form? 1 2 3 4 5 6 7. 8. So what is say that we remember that which ring is stable. First is 6 ring is more, then 5 ring, okay, then 8. So 8 ring is not so stable. So what we will make that, we will try to make 6 or 5 member ring. Okay, so like that I can make the bonds from here also. That's going to be, so where the ring will forms here. So if we look here, this is the negative charge is here. Okay, this negative charge, and this is the positive charge. Yes. So or if I rotate here, then this is going to be negative charge and this is going to be the positive charge. So this negative charge, and so we can make the bonds. So let's say that if we make the bonds from here, okay, so let's say this is 1 2 3 4 5 and 6. Yes, so if we make the bonds here, then 6 member ring will form, and 6 member ring is stable. 6 member rings, 5 member rings, these are the stable rings. So always try to make that 6 members or 5 member rings. So if we make from here that 6 member rings, then what it will forms. So 6 member rings we will make here, this one, this one, this one. Okay, so like this one. So here this negative charge and this positive charge I am making. Okay, so this one and that one I am making the bonds here. So now what you see that this will make that 5 bonds, means that this is the positive and negative, so that will make bond. So yes, so this negative charge and this positive charge make bonds. Now this has shifted to this, so that is shifted to here, and this is shifted to here. Okay, this is bonds, and rest what is remain here. So this rotations I did. So what how the rotations will be, this is rotate to here, and this will rotate to here. Okay, and this is rotate to here, and this is rotate to here, and this will make the, or I will solve these questions in the next class. So today after this we will solve more in the next class. Thank you.